Welcome to Laws of Indices Level 6. Pause the video now, try the 4 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're told that 1000 to the power of 6 minus 5d is equal to 1 over 100 times a cube root of 10, and we need to find the value of d. Now in problems like these, we'd like to write each side of the equation as powers of the same number. And we can see here that 1000, 100 and 10 can all be written as powers of 10. So starting with the left hand side, we can write 10 to the power of 3, because 1000 is 10 times 10 times 10, still with a power of 6 minus 5d on it, is equal to 1 over 10 squared, because 100 is 10 times 10, multiplied by the cube root of 10. Now going back to the left hand side, we can see that we're raising a power to another power. So we can use this law, which tells us that we need to multiply the powers together. So the left hand side of this equation becomes 10 to the power of 3 multiplied by 6 minus 5d. Now on the right hand side of the equation, we can see that in our denominator we have the cube root of 10. And this is the same as writing the cube root of 10 to the power of 1. And since 10 has a power and a root on it, we can use this law, which allows us to rewrite it as 10 to the power of 1 over 3, or 10 to the power of a third. Going back to the left hand side of the equation, we can expand the bracket, and we have 10 to the power of 3 times 6, which is 18, and 3 times minus 5d, which is minus 15d. This is equal to 1 over, and in our denominator on the right hand side, we can see that we're multiplying indices together. So we can use this law, which tells us that we need to add the powers to simplify. So the denominator becomes 10 to the power of 2 plus a third. Simplifying the denominator by adding together 2 and a third means our equation becomes 10 to the power of 18 minus 15d is equal to 1 over 10 to the power of 7 over 3, or 7 thirds. Now looking at the right hand side, we can rewrite this fraction using this law, and this means that 1 over 10 to the power of 7 thirds becomes 10 to the power of minus 7 thirds, and that's still equal to 10 to the power of 18 minus 15d. Now since we now have an equation which has the same base on both sides, we can say that the powers on each of these 10s are equal to each other. So this means that 18 minus 15d must be equal to minus 7 over 3. To start solving this equation, we can first subtract 18 from both sides. And so we have minus 15d is equal to minus 7 over 3 minus 18. And minus 18 can be rewritten as minus 54 over 3. And minus 7 over 3 minus 54 over 3 becomes minus 61 over 3. Finally, to get d on its own, we can divide both sides of the equation by minus 15, and this gives us d is equal to minus 61 over 3 divided by minus 15, which gives us positive 61 over 45. And that's our final answer for problem 1. In problem 2, we're told that p is equal to 25 to the power of x, and we need to express 125 over the square root of 5 to the power of 12x plus 6 in terms of p. Now in order to write this in terms of p, we would like to write the whole expression in terms of 25 to the power of x. To start, we need to rewrite the numerator and the denominator as a power of the same number. And we can see here that 125 and 5 can both be written as powers of 5. So starting with the numerator, we can rewrite this as 5 to the power of 3, because 5 times 5 times 5 is 125. And our denominator remains as the square root of 5 to the power of 12x plus 6. Now in our denominator, 5 is written using a power and a root. So we can use this law to rewrite the power on that 5 as a fraction. And the law tells us that this becomes 5 to the power of 12x plus 6 over 2. And our numerator stays as 5 to the power of 3. Now 12x plus 6 divided by 2 is equivalent to 6x plus 3. So we now have 5 to the power of 3 over 5 to the power of 6x plus 3. Now in this fraction, we're dividing the numerator by the denominator. So we can use this law, which tells us that when we divide indices, we subtract the powers. So we have 5 to the power of 3 minus 6x plus 3. Now to simplify this power, we can think of the minus in front of the bracket as a minus 1, and we can expand the bracket. So this becomes 5 to the power of 3, and then minus 1 times 6x is minus 6x, and minus 1 times 3 is minus 3. Simplifying this further, we have 5 to the power of 3 minus 3, which is 0, minus 6x gives us minus 6x. Now, as mentioned at the start of the problem, in order to write this in terms of p, we need to write this in terms of 25 to the power of x. So we can use our power law in reverse to rewrite 5 to the power of minus 6x as 5 to the power of 2 to the power of x to the power of minus 3. And this works because 2 times x is 2x, multiplied again by minus 3 gives us minus 6x, which is the power that we had on 5. Now the reason we want to do this is because 5 squared is 25, and so our bracket becomes 25 to the power of x, which is what we wanted, to the power of minus 3. And since 25 to the power of x is p, this becomes p to the power of minus 3, and that's our final answer. Now, in addition to this, you could rewrite p to the minus 3 using this law, which means it becomes 1 over p to the power of 3. And this is an alternative answer that you could give for this problem, but not one that was necessary here. In problem 3, we're told that b squared multiplied by the cube root of b to the power of 5 over the cube root of 8b to the power of 2 is equal to h b to the power of g. And we need to find the value of h and g. Now, in order to find the value of h and g, we need to rewrite the left-hand side of the equation as a power of b. And in order to do this, we need to simplify the numerator, simplify the denominator, and then hopefully simplify the fraction to get it in the correct form. So starting with our numerator, we have b to the power of 2 multiplied by the cube root of b to the power of 5. And looking at the cube root of b to the power of 5, we can see that that has a power and a root on it. So we can use this law, which tells us that we can rewrite the cube root of b to the power of 5 using a fractional power. So this is equal to b squared multiplied by b to the power of 5 over 3 using our law. Now that we're multiplying these two indices together, we can use this law, which tells us that we need to add the powers together to simplify. So this becomes b to the power of 2 plus 5 over 3. And 2 plus 5 over 3 is 11 over 3. So we have b to the power of 11 over 3. Moving on to the denominator, starting with the cube root of 8, b to the power of 2, we can first say that the cube root of 8 is 2, because 2 times 2 times 2 is 8. So we can write this as 2 multiplied by the cube root of b squared. Now again, the cube root of b squared is b written with a power and a root on it. So we can use our fractional power law to rewrite this as 2 times b to the power of 2 over 3, which is just the same as writing 2b to the power of 2/3. And that's our denominator simplified. Putting this all together means that our original fraction, b squared times the cube root of b to the power of 5 divided by the cube root of 8b squared can be rewritten as b to the power of 11 over 3 over 2b to the power of 2 over 3. Now in this fraction we're dividing the numerator by the denominator, so we can use this law, which tells us that when we divide indices we subtract the powers. So putting a 1 in front of our b to the power of 11 over 3, we can start by dividing 1 by 2 and we get 1 over 2, or a half. And then b to the power of 11 over 3 divided by b to the power of 2 over 3 is b to the power of 11 over 3 minus 2 over 3. Now since 11 over 3 minus 2 over 3 is 9 over 3, we have a half b to the power of 9 over 3, and 9 over 3 is just the same as 3. So we end up with a half b cubed from our fraction. Now we know that this should be equal to hb to the power of g, because we're given that in the question. So comparing the two sides of the equation, we can get to our final answer, which is that h is equal to a half and g is equal to 3. In problem 4, we're simplifying 4p to the power of 8 q to the power of 6 raised to the power of a half over 27p to the power of 6 q to the power of 15 raised to the power of a third, all raised to the power of minus 2. Now to start, we can simplify the numerator and the denominator separately, and then hopefully simplify the fraction once that's done. So starting with our numerator, we have 4p to the power of 8 q to the power of 6 raised to the power of a half. And here we're raising powers to powers, so we can use this law, which tells us that we need to multiply the powers together. Starting by adding a 1 as the power on our 4, we can multiply 1.5 together to give us 4 to the power of a half. Next, we can multiply 8.5 together to give us p to the power of 4. And finally, we can multiply 6.5 together and we get q to the power of 3. Now, since 4 has a fractional power on it, we can rewrite it using this law, which tells us that 4 to the power of a half is exactly the same as 4 to the power of 1 square rooted. And we have our p to the power of 4, q to the power of 3 after it. Now the square root of 4 is 2, because 2 times 2 is 4, and 2 to the power of 1 is 2. So our numerator simplified becomes 2p to the power of 4, q to the power of 3. Moving on to the denominator, we can do this in a very similar way. 27 p to the power of 6 q to the power of 15 raised to the power of a third can be simplified by multiplying the powers together. So starting with 1 times a third, we have 27 to the power of a third. 6 times a third becomes p to the power of 2, and 15 times a third gives us q to the power of 5. We can 3, 2, 1. We can rewrite 27 to the power of a third using our fractional power law as 27 to the power of 1 cube rooted. And the cube root of 27 is 3, because 3 times 3 times 3 is 27, and 3 to the power of 1 is also 3. So we have 3 p to the power of 2 q to the power of 5. Now that we've simplified our numerator and our denominator, we can rewrite our original problem, which was 4p to the power of 8 q to the power of 6 to the power of a half over 27 p to the power of 6 q to the power of 15 to the power of a third raised to the power of minus 2 as 2p to the power of 4 q to the power of 3 over 3 p to the power of 2 q to the power of 5 raised to the power of minus 2. Now, since we have a negative power here, we can use this law, which tells us that this fraction can be rewritten as 3p squared q to the power of 5 over 2p to the power of 4 q to the power of 3 raised to the power of positive 2. Within our bracket, we're dividing the numerator by the denominator, so we can use this law, which tells us that when we divide indices, we subtract the powers. So starting with 3 divided by 2, this gives us 3 over 2. Next, we have p to the power of 2 divided by p to the power of 4, which is p to the power of 2 minus 4. And finally, q to the power of 5 divided by q to the power of 3 is q to the power of 5 minus 3. And this is still squared. Now, simplifying this, we have 3 over 2, p to the power of 2 minus 4, which is minus 2, q to the power of 5 minus 3, which is 2. And that is all raised to the power of 2. Now, once again, we're raising powers to powers. So we're going to multiply the powers together. And before we do that, we're going to put a power of 1 on our 3/5 at the beginning. So we have 1 times 2, which is 2. So we have 3/5 to the power of 2. P to the power of minus 2 times 2, which is minus 4. And q to the power of 2 times 2, which is 4. So q to the power of 4. Now 3 over 5 squared is the same as saying 3 to the power of 1 over 5 to the power of 1 squared. And once again, if we now multiply these powers together, we have 3 to the power of 1 times 2, which is 2, over 5 to the power of 1 times 2, which is 2, p to the power of minus 4, q to the power of 4. 3 squared is 9, and 5 squared is 25. So we get to our final answer, which is 9 over 25, p to the power of minus 4, q to the power of 4.